Okay, so what we're looking at is fraction within fractions. Now there's two methods that we can solve these, and most likely I have a feeling that y'all are going to like the second method over the first. Now the first method that we need to do to be able to simplify this is to get the numerator and denominator as a single fraction. So as we can see here, the numerator is already just one fraction, because we have 5 over x plus 4. However, the denominator is 2, because we have two fractions here. So what we need to do with this method is, well, we need to make that be 1. We need to have it be a single fraction. So, well, the 5 over x plus 4 is going to stay the same. Now, when we look at the denominator, we need then the denominators to be the same, because if the denominators are the same, then we can add them together. So this is kind of what we did last Thursday and Friday, adding and subtracting these rational expressions. So the first thing we're doing is looking to see, what does this denominator have that this one doesn't? Well, that would be what? 3x plus 4. So we're going to multiply it on top and bottom by x plus 4, so the denominators are going to be the same. Now we're going to do the same thing by going in the other direction. What does this one have that this one doesn't? And that would be x. So we're multiplying the 1 on the left by x over x, and we're multiplying the 1 on the right by x plus 4 over x plus 4. And we're doing this so that the denominators are the same. So on top, we're still going to have 5 over x plus 4. Now the 1 on the right, so we're going to have x times 1, which this will give us x. On the bottom, we're going to have x times x plus 4 plus. Now the 1 on the right, we are going to have to multiply through by 2. So we're going to have to multiply 2 by x and 2 by 4. Well, 2 times x is 2x. 2 times 4 is going to be plus 8. And it's over x times x plus 4. So we did this here so the denominators are the same, because once the denominators are the same, we can add these fractions. Okay. So any questions on this here so far before we add the fractions on the bottom? Okay. So when we add these fractions together, well, we're going to have x plus 2x plus 8 over x times x plus 4. Well, x plus 2x is 3x plus 8. Let's go. Yep. Over x times x plus 4. Any question on anything we've done so far? Are we good with this here so far? Yes? Okay. Now, really what we're saying is with these two here is that, well, x over 5 over x plus 4 is really being what? Divided by our 3x plus 8 over x times x plus 4, because that's really what we're doing. When we talk about fractions, it's really the numerator divided by the denominator, but we're just writing in a singular form. So once we get one fraction on top and one on bottom, we can really rewrite this, scroll down, as division, so that we can simplify this here. So once we got one fraction on top and bottom, we rewrite it as division. But we don't really divide fractions. We change it from division to multiplication and flip the second rational expression. We flip the second fraction. Any questions on this here so far? Well, if we want to be lazy, we can really say that these are combined because we're multiplying the numerators together and the denominators together. But what do we notice about top and bottom? X plus 4 and x plus 4 will cancel, yes? So what does that leave us with on top? 5x over 3x plus 8. And that's it. Questions on this here? Questions on anything we've done so far? Now, there are going to be restrictions for this here. But we're only going to look at them from the start. What's going to make the denominators be 0? And we're not even going to look into them that closely. Because we're really just seeing what's going to make these spots here equal 0. Well, one of them is going to be 0. But when we have the variable by itself, it is 0. And the x plus 4 and x plus 4, it would be what? Negative 4. And I have a feeling most likely it's not going to ask too much on the homework about this, because really, if we were looking for zeros, we'd actually have to look further than that. Because if we're looking in depth, we couldn't have anything in here, this whole term, be 0. So if we're really looking for zeros, we'd have to see what is going to make 1 over x plus 4 plus 2 over x be 0, because it is the entire denominator. So really, if they are asking for it, they're not going too far beyond what's going to make these individual fractions be 0. That's really as far as it's going to look. Okay? So any questions on this here? We feel, this isn't bad. Method 1's not bad, correct? Okay. But I still think you're going to like method 2. I think you guys are going to like method 2 a little bit better than method 1. Now, method 2 uses something called the least common denominator. Or really, it's going to be the term that when I multiply the top and bottom will eliminate every fraction out of the numerator and denominator. So if I look at the numerator, what would I need to multiply 6 over x minus 2 by? So the fraction reduces. So we don't have a denominator anymore. What would we need to multiply it by? Well, what happens if I multiply 6 over x minus 2 by x minus 2? What would happen? We just have 6 because the x minus 2 and x minus 2 would cancel. So part of the least common denominator for this is going to be x minus 2 because it'll simplify this fraction and this one. So what else do I need? Well, we need to simplify this one here, yes? So what would I multiply 3 over x by so that I just get 3 by itself? X. So the least common denominator for this here is going to be x times x minus 2. So if I multiply that by the top and bottom, all of our fractions are going to simplify. So what we're going to do is we're going to multiply this thing on top and bottom by x times x minus 2. Move that over. Now I'm going to write this out step by step so we can see this. And we multiply this by the top, we're only multiplying by the numerator. So the x minus 2 isn't going to change, but this x times x minus 2 is going to be multiplied by the 6. So I have 6x times x minus 2. And the same thing is true on the denominator. Again, when we multiply a whole number or a whole term by the fraction, it multiplies by what's on top. So the x times x minus 2 is going to multiply by the 1. So I have x times x minus 2. And this here is going to also multiply with the 3. We'll just have 3x times x minus 2. So I'm just multiplying this out here. I'm not going to actually distribute or do any of our multiplication steps at this point because we want to see if anything reduces, and stuff should reduce. Now, any questions on any of this here so far? So we're good with this here? Yes. Okay. So let's see what happens. Well, on top, the x minus 2 and x minus 2 would cancel, yes? Here, the x minus 2 and x minus 2 cancel. Here, the x and x cancel. So what's left in the numerator? Well, just 6x, yes? Let's see what's left in the denominator. X plus 3 times x minus 2. Did that simplify a little bit easier than the first one? I mean, we did one multiplication step, and now I don't have fractions in the numerator and denominator anymore. Okay. Now, unfortunately, we're not quite done. We need to clean up, especially the denominator. We can't leave it as x plus 3 times x minus 2. We'll have to distribute the 3. Well, 3 times x is 3x. 3 times negative 2 is negative 6. So we're multiplying through by that 3. 3 times x, 3 times negative 2. Now, x plus 3x is 6 over 6x. Is there anything we can do with this here? Well, we can't quite factor out the 6 because the 4x and negative 6 are kind of stuck together. But there is a common factor between 2. There's a common factor of 2 between all of these terms. And if we did this individually, I would factor a 2 out of the denominator because that's the biggest number I can factor out of 4x and 6, which would leave us with 2x minus 3. And well, these here will simplify because 6 over 2 is the same as 3. And leave me with 3x over 2x minus 3. And that's it. So we had to factor out the greatest common factor to get down to this here. And you probably noticed by this point a lot of the assignments are wanting you to factor it all the way down if possible. If it factors, you need to factor it. Even if nothing cancels, it still wants you to factor it. So this here is our answer. Questions on this here? Any questions on anything we've done so far? Be good with this here? Yes? Okay. Let's look at another one. Now this one here only has numbers, so we don't have any variables in the denominator. But we have 6, 3, 5, and 10. Now we're still looking for a least common denominator. We're looking for a number, so this one here is just numbers, a number to multiply each of these terms by so that the denominators simplify out. So I don't have fractions in the numerator and denominator. So we're looking for a number that will be divisible by 3, 6, 5, and 10. 30. 30 will be the first number, and it's going to be the best one. Now, when we looked at this here, I mean, 60 would work. 60 would be a number that works, but we would have a common factor of 2, an extra one, that we would have to factor out later. So, since we found this term of 30, that's going to simplify each one of these, we can multiply on top and bottom of this fraction by 30. And when we do this here, we're multiplying each term on top of this fraction by 30. So 30 times x will give us, well, 30x over 6 minus 30 times x would be 30x over 3. We do the same thing on bottom. 30 times x would be 30x over 5 minus 7 times 30 is 210 over 10. So we multiplied each numerator of each fraction in this fraction by 30. Any questions on this here so far? Now, the first thing we can do is 30 divided by 6. Well, 30 divided by 6 is 5x. 30 divided by 6 is going to be 5x. Now, 30x divided by 3 would be what? 10x. That takes care of the numerator. Now we can look at the denominator. 30x divided by 5 would be 6x minus 210 divided by 10 is 1. So we simplified this down here. Now the numerators, we can combine those because 5x minus 10x is negative 5x. Well, 6x minus 21, we can't combine them, but there is a greatest common factor of what? 3, which leaves us with 2x minus 7. And that's as simplified as it gets. Any questions on any of these here? You're ready to look at another one. Okay. So we'll look at this one here. So we have 2 over x minus 4 over 2 over x plus 3. So again, we want to multiply the numerator and denominator of this fraction by something so that the fractions in the numerator and denominator will simplify out. So what would I need to multiply the numerator by so all the fractions simplify? So we're looking at this here, yes, the 2 over x. So we're wanting that fraction to simplify. So what would we multiply it by? X. So what about the denominator? Well, we'll need x. But is there anything else that we need besides x? Well, now we have the 2 over x and 2 over x, yes? Because x divided by x is 1, so it would simplify. So here we only need to multiply the numerator and denominator by x. So if we multiply through, again, we're only multiplying by the top terms of fractions, so x times 2 would be 2x divided by x. Not plus, then it would be minus, well, 4 times x is 4x. On bottom, we'll have 2x over x, because 2 over x times x will be 2x over x, plus 3 times x would be 3x. Any questions on this here so far? Okay, let's see what simplifies. Well, the x and x will simplify. The x and x will simplify. And if we simplify these out, I'm left with what? Negative 4x plus 2. And I switched them because I want to put the variable in front. There's nothing wrong with this. Because the x over x simplified and just left us with 2, and I just moved the 4x in front. If we do that on bottom, we'll move 3x plus 2. Now, there's one last thing we can do, is looking at this here, is there any kind of factoring that we can do with this on top and bottom? Well, negative 4x plus 2, there's a greatest common factor of 2. And so we'll take a negative 2 out so that the x is positive. So we can take out a negative 2 or a 2 either way. So if we factor out a negative 2, well, negative 2 out of negative 4x leaves us with 2x. Now, since I pulled a negative out, the positive becomes a negative, and 2 factored out of 2 is 1. Now, we can't do anything with the denominator, so it just stays 3x plus 2. Any questions over any of this here? Okay. So let's look at this next one here. 3 over x plus 5 over 2 over x minus 3 plus 1 over x plus 5. So again, we need to find a least common denominator that we can multiply the top and bottom by so that all the fractions simplify. Well, that's one of the things that we will have. Yes. X minus 3. Because each one of those are together. The x plus 5 is one whole term because of the plus. And the x minus 3, those are locked together. So to fully simplify everything out, I need to multiply the top and bottom by x plus 5 times x minus 3. Now, even though x plus 5 appears once on top and once on bottom, I don't need it more than once because it only appears in each one of those spots once. So we can multiply through by this here. So we can multiply the top. So this here is going to multiply by the 3 because, again, when we multiply by fractions, we multiply by the numerator. So we have 3 times x plus 5 times x minus 3. And that's it for the numerator. Now for the denominator, we're going to multiply each one of these terms by this whole thing. So we'll have 2 times x plus 5 times x minus 3 all over x minus 3. Plus, we're going to multiply this whole thing by 1, which will just be x plus 5 times x minus 3. And this is going to be over x plus 5. So any questions on how we multiplied any of this stuff together? or how we did any of this here. Now this point here will cancel out like terms, so the x plus 5 and x plus 5 will cancel in the numerator. In the denominator, the x minus 3 and x minus 3 would cancel. And then we'd have an x plus 5 and x plus 5 cancel. And that's what we wanted. We wanted these fractions to simplify completely. So what that leaves us with on top is 3 times x minus 3. Now on the bottom we have 2 times x plus 5 plus x minus 3. So that's what we have left. So looking at this here, is anything being added or subtracted, or more than one set of parentheses being added or subtracted in the numerator? Well, no, we just have 3 times x minus 3, yes? So to get it simplified, I really don't have to do much with this here. I mean, I can multiply through by the 3, but if there's a greatest common factor of 3 on top and bottom, I would have to factor it back out, or vice versa. We're going to have to get back to it, yes? So unless there's more than one set of parentheses, like the denominator, on top or in either spot, then we would multiply through so that we can simplify. But because this is only one set of parentheses, we can leave it alone. Because I did it in first hour, we multiplied through by the 3, but then we had to factor it right back out. Now because there's 2 sets of parentheses in the denominator, we are going to have to simplify it. Because I'm going to have to distribute this 2. We're going to have to do 2 times x, which is 2x. And 2 times 5 is going to be plus 10. Plus x minus 3. Now, the numerator doesn't change, 3 times x minus 3. Now, we do need to combine like terms in the denominator. Well, 2x plus x would give me what? Well, 3x. 10 minus 3 would be plus what? 7. Yes.
They both had x before you multiply 3.
Mm-hmm.
Had 3, or I mean x minus 3 on both top and bottom. So
Yeah.
why can't you factor it out?
Because of the plus sign. Because it's almost like we have another set of parentheses. Because these two here are stuck together because of the addition. So we can do that cancellation on top and bottom if it's multiplication, but we can't do it if they're addition or subtraction. And it's really that whole simplification is, with the multiplication is coming to the fact that if I have a times b over c times b, because I can split multiplication back apart to a over c times b over b. Anything divided by itself is 1. So I can simplify it to a over c. Now, unfortunately, with c plus b, because I can't separate those two like I can with multiplication, it doesn't work that way. These here are stuck together. It'd be nice if it did, but unfortunately, it doesn't work that way. Any other questions on this here? All right, let's look at this one here. So we have 1 over a minus 3 over a minus 2, all over 2 over a plus 5 over a minus 2. So to make this a little bit easier to work with, we need a least common denominator that we can multiply the numerator and denominator by, so that we can turn these, the two fractions in the numerator and two fractions in the denominator, as a single fraction. Now, what do you think we can multiply the numerator and denominator by to simplify this down? Yep. A and A minus 2. Because the A, when multiplied by 1 over A, would simplify that fraction. The A minus 2 will simplify the 3 over A minus 2. And the same for the denominator. The single A will simplify A, and the A minus 2 will simplify the A minus 2. And we only need these as many times as they show up. Since A minus 2 only shows up once in each fraction, we only need it once. A only shows up once in any of the fractions, so we only need it once. Now we can multiply through. So this here is going to multiply by each of the numerators. So we'll have A times A minus 1, A minus 2 times 1, which will just be A times A minus 2. Now we're going to do 3 times A minus 2, which will be 3A times A minus 2. And that takes care of the numerator. We've multiplied it by both of those. Now we can do the same thing for the denominators. We'll multiply by the 2 and 5. So we'll have 2A times A minus 2, because we're multiplying those two together. And this is all over A. Plus, we're going to multiply this whole thing by 5, which will just give us 5A times A minus 2 all over A minus 2. Questions on this one here? Okay.
You're multiplying on the fractions, you're multiplying into it. Why do you only multiply the first A?
Yeah. So it's almost, because A, right, it's outside the parentheses. It's just, this is going to be the number first. 5 times A times A minus 2. So we could have written it as, so like the top, or let's just say 3A, this one here. I could have written it as 3 times A times A minus 2 with parentheses around all of it. But 3 times A is just 3A. So we don't necessarily put parentheses around it. So we're just multiplying each one of them together. It just works out that 3 times A is 3A. So we almost multiply those two straight out times the A minus 2. Does that kind of make sense? So it's almost, we could write the parentheses around it and then multiply, or just connect those two together. There's not a whole lot of difference between that. Any other questions? Okay. Well, let's see what's in common on top and bottom. Well, we have the A and A. We have the A minus 2 and A minus 2. Here we have the A and A. And A minus 2 and A minus 2. So now when we simplify this here, let's see what's left in the numerator. Well, we have A minus 2 minus 3A. And in the denominator, we have 2 times A minus 2 plus 5A. Now, we didn't necessarily have to do the parentheses in the numerator because 3A is just a term. But if we have more than one term, it's going to be wise to put the parentheses around it, because that negative is going to affect both, or all the terms inside this set of parentheses. But since we just have one term, it is already taken care of. But if we had two, we need to be careful to make sure that the negative transfers to both terms. Any questions on this here so far? Okay? Well, we can go on and simplify this here. So we have a minus 3a minus 2 on top. And I just rewrote these in a different order. I just moved the 3a next to the a. It's going to be the exact same thing. Now we can distribute the 2 on bottom. 2 times a is going to give me 2a. 2 times negative 2 is going to give me negative 4 plus 5a. Now a minus 3a is going to give us what? Negative 2a minus 2 on top. On bottom we have 2a plus 5a would be 7a minus 4. And we get this here. Is there anything we could do with this here to simplify it a little further? Was there a common factor on top? 2. And we can almost take negative 2, especially since they're both negative. Well, negative 2 out of negative 2a leaves me with a positive a. The negative, pulling out a negative makes it positive, and it would be 1 over 7a minus 4. Now, even though it really didn't simplify, they still want us to factor it out, just so we have this here. Any questions on any of this here so far? AJ, we got any questions? Okay. We're going to stop here because I'm going to finish this up tomorrow. And we'll go on and finish all of the note sheets tomorrow.